Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing graph intersection. This is part 2, so you should have watched part 1 before attempting to watch this video. The table shows some values for y equals x squared minus 1 over 2x. X is not equal to 0. Complete the table of values. So let's just look at the answer together and attempt to understand what is going on. So to complete the table of values, to get these values here, all you have to do is simply plug the x values into this equation. So for example, if we have negative 1 squared minus 1 over 2 times negative 1, we get 1 plus 1 over 2, and this is equal to 1.5. So by repeating the same procedure again with the different values of x, you can get the corresponding values of y for each, and we get these answers right there. In B, we are told, on the grid, draw the graph of y equals x squared minus 1 over 2x for negative 2 to 0.2 and 0.2 to positive 2. So all we have to do for B is to just graph these points here. So negative 2 and 4.25, for example. In order to graph correctly, you must figure out the ratio between boxes and units. So for example, on the x-axis, to go from 1 to 2, we have 20 boxes. So 20 boxes are equal to 1 unit. We want the value of one box. So one box is equal to 0.05 units. What does this tell us? For example, this tells us that here we have 0.05, and here we would have 0.1, and so on and so forth. Each small box is worth 0.05 units. So to get negative 2 and 4.25, we also need to figure out the ratio between boxes and units for the vertical. So for the vertical here, we have 10 boxes worth 1 unit. So one box will be worth 0.1 units. And we go to the first point. We go to negative 2 on the x-axis. There it is. And we move up to 4.25. So this is 4. This is 4.1. This here would be 4.2. So our point has to be between, excuse me, I made a mistake in counting. So 4.1 and then 4.2 right there. And then right above the point, you will have 4.3. So our point is between 4.2 and 4.3, right in the middle at 4.25. And again, you repeat the same procedure for each pair of these points until you have all the plotted points correctly drawn. These are drawn in red in the diagram, so the red points are corresponding to the table. The lines that have other colors will come later on in the problem, but for problem B, all the red stuff on the graph represents the points in the table. After we're done plotting the points, we join them together in smooth curves as much as possible. So you should not be drawing broken lines. It should not look something like this. This is not a correct curve. It looks similar to ours, but this is not correct. It has to be one smooth curve for the set of points in the negative as well as the set of points in the positive. In C, we are told, by drawing a suitable line, use your graph to solve the equation x squared minus 1 over 2x equals 2. So x squared minus 1 over 2x is the graph that we already drew on the grid, because this was the equation of the graph that was used to create the table to begin with. We want to solve it equal to 2. So what we need to do here is simply solve it graphically. How do we do that? We already graphed y equals x squared minus 1 over 2x. Now we graph y equals 2. Y equals 2 is basically a horizontal line, and you will see it here graphed in blue. So in general, the blue stuff on the graph corresponds to the blue answers in the question. So question C is solved using the blue lines on the graph. Question D is solved using the green line, and question E is solved using the purple line. This is the key. So the colors are not random, they are matching each other. So you should be focusing right now on the blue part on the graph. We drew the line y equals 2, which cuts the y-axis at 2 and is a horizontal line. So we want a horizontal line cutting the y-axis at 2. And we just stretch the line from right to left, of course. And we see where it cuts the red graph. So the points where they meet are these points here. Watch out, this is not the red point. This is another point slightly to the right, where the blue line intersects the red curve. And also here, this point here, this is where the blue line intersects the red curve. And we get the x values of these points. So we have negative 1.3, negative 0.26, and 1.55. These are the x values of the points of intersection, and these are our answers to question C. For question D, we are told the equation x squared minus 1 over 2x equals k has only one solution. Write down the range of values of k for which this is possible. So what you need to understand here is that, again, these are solved graphically by graphing this equation, which we have already done. This is the red graph. And also graphing the equation y equals k. So y equals k is another horizontal line cutting the y-axis at the value k. And we want them to have one solution. One solution means one intersection point. So we want a horizontal line that intersects the curve only once. So let me draw a couple of lines and let's discuss together whether these intersect once or more. So for example, what about this line here? What about this line here? How many points of intersection do they have with the red graph? For the top line, you might want to say 0. There are no points of intersection, but this is not correct because we should understand that the function will keep going beyond this point. So this function will keep going like this, and it will also keep going like this, and it will also keep going like this, and so on and so forth. So if we plot more points, this is the complete function. So in fact, for the first black line, it cuts the graph at 3 different points. Even though if we do not complete the drawing, it looks like it doesn't cut at all, but you should understand that the tips of the drawing will keep moving in the same direction. So this black line cuts 3 times. We're looking for a line that cuts only once. Again, here, this will cut 3 times. So these are all wrong, of course. So let's try different lines. Let's try, for example, a line here. Again, this will cut 3 times. This doesn't work. This green line here, this cuts the curve twice. So this green line itself would not work. So the value here is 1.2. So if I draw the line y equals 1.2, which is the green line that was drawn already on the screen, this cuts the curve at 2 different points. So it's not what we want. However, anything below the green line, any line below the green line will cut the curve only once. So anything less than this value would work. So k has to be less than 1.2, not less than or equal, because like we said, this would cut the curve twice. However, less than would work. By drawing a suitable tangent, find an estimate of the gradient of the curve at the point where x equals -1. So we should go to x equals -1 and draw a tangent. Make sure to have a proper tangent drawn. One way to evaluate your tangent is if the tangent meets at this point here. So the angle here and the angle here should roughly be the same. It's not an exact science. However, drawing a line like this might look like a tangent as well. But you can see here that the angle would be very big on the right and very small on the left. So this is not the proper tangent. So the purple line I drew seems to be doing okay because the angles are roughly the same. The width is roughly the same. And another piece of advice is to not take points on the tangent that are close to each other. So I didn't even use this point, even though it does belong to the purple line, and we already have the coordinates of it from the table. So the coordinates are there. I would not advise that you use this. I would advise that you choose two far away points to evaluate the gradient, because the further away they are, the more accurate your answer is likely to be. So now that we have the points we need, we plug them into the equation of the slope. So for the equation of the slope, we just do y2 minus y1 over x2 minus x1, and the answer will be negative 1.39. Of course, this is not an exact answer. It just needs to be within the correct range. So, for example, negative 1.39 lies between negative 1.3 and negative 1.7. So we know that it's correct. For k, it needs to be less than 1.2. And this is correct as well here. For these blue answers, we have negative 1.3, negative 0.26, and 1.55. These are correct as well. 1.55 is there. Negative 0.26 is within the given range, as well as negative 1.3. So this is the basic idea of how to solve graph intersections. Of course, in the following problems, I'll be moving a little bit quicker. So this is the next problem here. Again, in A, we are required to complete the table of values, and all that I need to do in order to do that is just plug these values of x into this equation here, and I get the corresponding values of y. Then we are required to graph. Again, I will remind you to make sure you have a correct ratio of boxes to units. Let me do that here quickly. So 1 unit here equals 10 boxes. So 1 box equals 0.1 units. This is the scale here on the x. And on the y, you have 10 boxes for 5 units. So 1 unit, excuse me, 1 box is equal to 0.5 units. So this goes 0.5. Excuse me, I must have made a mistake. I'm moving horizontally instead of vertically. This is my bad. So I meant on the y-axis, this is 0.5, 1, 1.5, 2, 2.5, 3, and so on and so forth. So you use these ratios in order to accurately plot the points of the table onto the graph. In C, we're told by drawing a suitable tangent, find an estimate of the gradient of the graph at the point 111. So we go to point 111, which is part of our plotted graph, and we draw a tangent like we did before, and we make sure that the angles are close enough to each other, and then we pick two faraway points, and we attempt to calculate the gradient using these points. So, excuse me. So I did 21 minus 0 divided by 0 minus 2, and I got negative 10.5 for the gradient. In D, we are told the equation x squared minus 2x plus 12 over x equals k has exactly two distinct solutions. Use the graph to find the value of k. So we want to graph a line of some sort such that it intersects our curve. Remember, this is the equation of the curve here. So we want to graph y equals k such that there are two solutions of the equation. So two solutions here. This means that we have 2 points of intersection. Two intersections here. So what horizontal line would cut the curve exactly twice? Let's look at the graph, and I remind you that the graph extends further beyond this drawing. In order to have two distinct solutions, the following graphs would work. So for example, this here would work, this here would work. Starting this line that I'm about to draw in yellow, this line here cuts the graph 3 times. So starting this value, it would not work up until the blue line. So these would not work. Excuse me, so I said something that was incorrect. I apologize for that. The black lines would not have worked either because, like we said, this red line here would extend like this. So actually, all these black lines would cut the curve 3 times. All of these are incorrect lines. The only line that is correct is the blue line drawn on the graph, because anything below the blue line would cut the curve only once. So here you have 3 intersection points, and anything below the blue line would have only 1 intersection point. So the only line that would cut the curve exactly twice is the blue line here. So this blue line is touching the curve at this point and cutting the curve at this point. So we get the value of y. The value of y is 1 box above the 5. And we said that the box here is half a unit. So it's 5.5. So the value of k is 5.5. And to get the actual solutions, we just see the x values of the points where the blue line cuts the red graph. We check the x values, and they are negative 2.35 and positive 2.3. Now that we have our solutions, we move on to E. So for E, we are told the equation x power 3 plus ax power 2 plus bx plus c can be solved by drawing the line y equals 3x plus 1 on the grid. Find the value of a, b, and c. So the way to do this is first to write our normal equation here. So we have x squared minus 2x plus 12 over x. And this is solved by drawing this line. So obviously we're going to find their intersection. So we're going to equate this to 3x plus 1. Now we can simplify. We can take these two to the other side. So it becomes x squared minus 2x plus 12 over x minus 3x minus 1 equals 0. And we can further simplify this. So these together would be minus 5x. So let me rewrite it. It will be x squared minus 5x minus 1 plus 12 over x equals 0. Now, I can't solve this as or I don't want it to be a rational equation. I want something over x. I'm allowed to multiply everything by x on both sides. So I'm going to multiply here by x, and I'm going to multiply here as well by x. So the equation becomes x power 3 minus 5x power 2 minus x plus 12 equals 0. And they said that the equation is x power 3 plus ax power 2 plus bx plus c equals 0. And they want the values of a, b, and c. Of course, plus a is equal to negative 5. So a equals negative 5. Positive b is negative 1 here. So b is negative 1. And finally, c is 12. So negative 5 and negative 1 and 12 are the correct answers to this problem. Here again, we have another equation with a table of values. So let's begin. So for A, again, we plug the values of x into the equation and we get the values of y. For B, we plot the points, and I will remind you of getting the units and the boxes. So for the x-axis here, you have 1 unit in 5 boxes. So 1 box is 0.2 units. So it goes, for example, negative 0.2, negative 0.4, negative 0.6, and so on and so forth. And then for the y-axis, we have 1 unit here in 10 boxes. So 1 box is worth 0.1 units. So this, for example, would be 4.1, 4.2, and so on and so forth. This is important in order to establish the scale of your graph. In C, we are required to solve f of x equal to 0. So the red graph is f of x, and we want to know where it cuts the x-axis, because f of x equals 0 means that y equals 0. So we want to know where on the graph y is equal to 0. So y is equal to 0 on the x-axis. So we're looking for the following points. Actually, it's only 1 point right there. And this is 1, 2, 3, 3 boxes to the left of -2. And we had already said that each box is worth 0.2. So 3 boxes would be 0.6 on the left of -2. So it would be -2.6. This is how you find the value. You have to move from -2 to the left, 3 boxes. So we're going towards -3, and 3 boxes are worth 0.6. So it becomes -2.6 as a final answer. Now, by drawing a suitable line on the grid, solve the equation f of x equals 1 minus x. So we are supposed to graph this line here, 1 minus x. The way to do that is to create a small table. Knowing that this here is just x power 1, you just need 2 points because the graph will be a line. So if x is 0, y is 1. If x is 1, y is 0. I'm just going to plot 0.01 and 0.10. And this is what I did on the graph. So the line goes from 0, 1, which is this point here. So there seems to be a mistake here. Oh, we're talking about the blue line. Excuse me, this is my mistake. So 0, 1, this is the point here. This is 0, 1, and 1, 0. And we join them together, and we create the line that we want. This blue line cuts the red curve at a certain point, which is this point here. So we try to find the x value of this point, and we get -1.6 again. -1 is here, and we move 1, 2, 3 steps. So it's -1.6. So therefore, the x value here is -1.6. Finally, we want to draw a tangent at the point -3 and -0.6. So for -3, -0.6, this is a point on the red curve, which is right there. And we draw a tangent at this point. Remember to make sure that the tangent is well balanced. And then we take any random 2 points on the tangent and find the gradient. I chose faraway points, like we said before. I plug them into the equation of the gradient, y2 minus y1 over x2 minus x1. And I got the value of the gradient as 1.1. Let's see if our answers are within range or not. So we have a correct gradient has to be between 0.9 and 1.5. And our answer is 1.1, so that's okay. This is the purple answer. And then for the blue answer, -1.6. And the range is from -1.6 to -1.5. So again, we are within range. For the red answer, -2.6 is okay as well. It lies between -2.6 and -2.4. And the values of the table are 1 and 3 and 2.5, and these are correct as well. So for the following problem, let's check it out. Question A is the same. We have to plug 5 and 8 into the equation above in order to get the y values. And then for B, we are supposed to draw the graph. And the graph here, again, is drawn in red. So you should be focusing on the red graph for now. In C, we are told, using your graph, solve the equation f of x equals 11. So to solve the equation f of x equals 11, I need to draw y equals 11 and see where it cuts the curve. So I'm going to go to 11, which is halfway between 10 and 12. And I'm going to draw the horizontal line. I'm going to see where it cuts the red curve. So it cuts at this point and at this point. I'm going to find the x values of these points. And these turned out to be 2.6 and 8.8. So these were the answers that I wrote right there. For question D, we are told k is a prime number and f of x equals k has no solution. Find the possible values of k. So f of x equals k means that we are drawing a horizontal line y equals k. No solution means that it does not cut the red graph at all. So we want to draw horizontal lines that do not cut the red graph. And of course, there are a lot of them. We can draw many different lines like this. All of these would not be cutting the red graph at all. However, we have some restrictions. K needs to be a prime number. So prime numbers cannot be negative to begin with. And not all numbers are prime, obviously. So looking at the positive region here, what prime numbers exist between 0 and 8? So we have 2, we have 3, we have 5, and we have 7. These are the prime numbers that exist between 0 and 8. And if k is equal to any one of those, the horizontal line, would not be cutting the graph. So 2, 3, 5, 7 are all correct answers. And you actually need to write them all because they didn't want a possible value. They wanted all the possible values of k. For question C, we're told the gradient of the graph y equals f of x at the point 212 is -4. Write down the coordinates of the other point on the graph of y equals f of x where the gradient is -4. So at the point 212, which is this point here, the gradient is -4. What other point on the graph has a similar gradient? So you can see here that the red graph is kind of symmetrical. Let me just highlight it for you so that you understand what I'm talking about. So this is the first part of the red graph. And the second part is the one below. And you can see that there is some sort of symmetry between them. They're reflections of each other. And even if you look at the table, you will see that all the values are exactly the same, however, in the negative sense. However, all the y values are exactly the same. You have 14.1 negative and positive, 12 negative and positive, and so on and so forth. So from the symmetry, just take a guess. If 2 and 12 has this slope, -4, it's very likely that this point will also have the same slope. Let's try to draw a tangent and to check whether this is true or not. So for -2 and -12, the tangent would look something like this. And you can see clearly here that the two black lines are parallel to each other. The two tangents that we drew are parallel to each other. Therefore, they have the same slope. So by symmetry, the other point is just going to be -2 and -12. For question F, we are told in I, the equation f of x equals x squared can be written as so and so. Find P and Q or show that they are equal to certain values. So f of x equals x squared. Excuse me. Let's just write this down somewhere on top. So f of x is 20 over x plus x. This is the equation given at the top of the page. And this is now equal to x squared. Let's take these to the other side. So we get x squared minus x minus 20 over x. Excuse me, minus x minus 20 over x equals 0. Let's multiply everything by x to get rid of the denominator. So 0 times x, of course, is 0. 20 times x over x, these would cancel out, so you get minus 20. X squared times x is x power 3. Negative x times x would be negative x squared. So this is our equation here. And they want P and Q. P is the number next to x power 2, and Q is the number after it. So P will be -1, and Q will be -20. Having found P and Q, let's move on. On the grid opposite, draw the graph of y equals x power 2 from -4 to 4. You will see the purple graph drawn on the grid. Of course, if you want the table for it, you have x and y equals x power 2. They want from -4 to 4. So I just chose a couple of numbers. I chose -4, -2, and 0, and 2, and 4. So this here is 16, 4, 0, 4, 16. These are the points. I just square each number. I square each x to get the y. And if you plot these points, -4 and 16, -2 and 4, and so on, you will get the purple graph. So having drawn the graph, we are now required to solve the equation x power 3 minus x power 2 minus 20 equals 0. So what is this equation? What is x power 3 minus x minus 2 minus 20 equals 0. How do we solve this equation?
So the idea is that we already got this equation when we were trying to equate the two graphs. So this equation here comes from what? It comes from this initial equation, which is 20 over x plus x equals x squared. So if we draw y equals 20 over x plus x, and we draw y equals x squared, where they intersect, this will be the solution of the equation. Luckily for us, this has been already drawn. This is the red graph, and this is the purple graph. So the solution to our equation, very simply, is the point of intersection between the purple and the red, which is this point here. And this is equivalent to 3.2 on the x-axis. This is the x-coordinate of the point. So therefore, without any calculation, the solution is 3.2. Finally, in IV, we are told that they graphed this graph here, and they want to find the value of n, which is the x-coordinate of point P. So, like we just said, this value must make y equal to 0 because it's on the x-axis. So we have a point n comma 0, like they said here. So if y is 0, then we're basically solving this equation equal to 0 again, since it's the exact same equation here. So the value that we got here must be the value of n without any calculation again. All we have to do here is just understand that n is equal to 3.2 as well, because it is the solution of the equation. These are the correct answers, and they are similar to the ones that we got. So, not to bore you with repetitive details, let's just go through the new concepts in this question. In A, we complete the table. In double I, we draw the graph. The red graph is it's the same idea as what we did before. We want to solve f of x equals 0. So f of x equals 0 is basically where the graph cuts the x-axis. So we're looking for the blue points. These blue points here, these will be the solutions of f of x equals 0, because these are the points where the graph cuts the x-axis. Now, having obtained these points, the x values of these points, of course, I will remind you that you have to get the ratio between boxes and units. I will not bore you with the details because by now you must have understood how this is done. So after getting the correct values of x, we move on to question C, which says find an integer k for which f of x equals k has one solution. So we want to find an integer such that the horizontal line y equals k has one point of intersection with the red curve. And I remind you again that this curve actually extends like this as well, and down below as well. So we want to take this into consideration while we are searching for the horizontal line. It's very evident here that the horizontal line which would cut the curve only once is any line below this line that I'm drawing right now. So this blue line cuts the curve twice, but any line below the blue line, so any of the green lines here, all of these would cut the curve only once. So any value between -3 and -10 would actually work. Even if you decide to write -11 or -12, even though it's not on the graph, it would still work because, like we said, the graph extends downwards outside of our grid. So any value starting -3 would work. -3, -4, -5, any of these would work. In DI, we are told by drawing a suitable straight line, solve the equation f of x plus 2 equals -5x. It's the same question again, just presented a little bit differently. How would we be able to solve this equation here? We want f of x to be alone, so we'll take the 2 to the other side. So f of x equals -5x minus 2. To solve this equation, we graph the left-hand side, we graph the right-hand side, and we see where the two graphs intersect. Luckily, we've already graphed the left-hand side. This is the red graph, and we need to graph this line here. So -5x minus 2, let's just put x as 0 and 1, for example. If we put x here as 0, we get -2. If we put it as 1, we get -7. So we want to draw a line between 0, -2 and 1, -7. And this is what I did here in the purple line, 0, -2, 1, -7. I joined the 2 points together and I extended the line, and it cuts the red curve at this point again, which is the blue point that we already found when we were trying to find the x-intercepts. So this is one of the solutions. And another of the solutions is this point here, where the purple line cuts the red graph, and we get the x value of this solution by just looking at the x-axis here. You will find that the solution is 0.65. So these are the two solutions where the purple line cuts the red graph, and these would be the solutions to our equation. Finally, we are told f of x plus 2 equals -5x can be written as blah, blah, blah. Find the value of a and b. So we begin by replacing f of x. So f of x is x squared minus 1 over x minus 4 plus 2 equals -5x. This is what I did here. And then I took the -5x to the left-hand side, and I rearranged them from high power to low power. So x power 2. So this should have been plus 5x, not -5x. Yes, this is actually a mistake here. This should have been plus 5x because the 5x will acquire the opposite sign. And then, excuse me, so there seems to be a mistake here. No, it's just this issue. So this should have been plus 5x. And then -4 plus 2 gives us -2. And we have the -1 over x as well. So let me just write this down so that you don't get confused. Let me resolve it at the top here. So we are trying to solve the following equation. F of x plus 2 equals -5x. F of x is the equation given at the top of the page, x squared minus 1 over x minus 4 plus 2 equals -5x. We take the -5x to the other side. It becomes x squared minus 1 over x. These two together give us -2 and plus 5x equals 0. Let's multiply everything by x. So the first term here becomes x power 3 minus, and then if we multiply here by x, these cancel out, so this becomes 1. And then minus 2x plus 5x power 2 equals 0 times x. So we have to multiply here as well. But 0 times x is 0 anyway. Now let's arrange them from high power to low power. X power 3 plus 5x squared minus 2x minus 1 equals 0. They want the value of a and the value of b. So a is 5 and b is -2. So it seems that I got a equal -5. Let's see which answer here is correct. So a is supposed to be +5 and not -5. This was a small mistake that I did here. This was incorrect. However, this answer that we got here is the correct answer. Again, this question is a little bit different than what we did before. The diagram shows the graph of y equals f of x. Find f of -2. So f of -2 on the graph is the y value for when x is -2. So we go up here and we get the y value. And this is what I did here. So the y value is at 10.1. Excuse me, the y value is exactly at 10. The y value here is exactly at 10. It's not the maximum. It's slightly to the right of the maximum. So the y value is 10, and that's why I wrote 10 in I. In double I, we are told solve the equation f of x equals 2. So to solve f of x equals 2, I need to draw a horizontal line that cuts the y-axis at 2. And this horizontal line will intersect the black curve at 3 points. I need to get the x value of each point. And these are the numbers written in blue as well, 1.7, negative 0.35, and negative 3.3. So these are the answers to double I. In triple I, we are told two tangents, each with gradient 0, can be drawn on the graph. Write down the equation of each tangent. So gradient 0 means that we have a horizontal line. It's neither upsloping nor downsloping. It's just a horizontal line. So we want a horizontal line that can be drawn as a tangent to the graph. So the lines that satisfy this requirement are the purple lines here. These are the horizontal tangents to the curve. We just need to know where they intersect the y-axis. So here it intersects at negative 2.2. So the equation is y equal negative 2.2. And for the other line here, it intersects at 10.1. So y equals 10.1. These are the equations of the lines that are tangent to the graph and that are horizontal tangents. These are written in purple next to triple I. For B, we are told complete the table for g of x equals 2 over x plus 3. Again, we just plug the x into the function to complete the table. And then we're required to draw the graph. And this is the graph drawn in red on the grid. Use your graph to solve f of x equals g of x. So f of x equals g of x basically means we are looking for the intersection between red and black. So where does the red curve that we drew intersect the black curve that is already drawn in the question? So we just find the intersection points, and they are labeled in green here. This intersection point and this other intersection point, we find their x values on the x-axis, and we get 1.85 and negative 3.28. So these are the solutions to this problem. In C, we are told find g of f of negative 2. You need to be a keen observer here to just realize that f of negative 2 has already been obtained in AI. If not, you can just go back to negative 2 on the x-axis and try to find the value of the curve that satisfies it. You'll be repeating the same process again, but anyway, the value is 10. So g of f of negative 2 is the same as g of 10. Now, g of 10 is basically the value of y when x equals 10. However, we cannot get that from the graph because the graph does not reach until x equals 10. But we can get that from the equation here. So 2 over 10 plus 3, this is equal to 3.2. So the answer here is 3.2. For D, we want g inverse of 5. So this is the same as saying find x when y equals to 5. In the table, we are already given y equal 5. So by just checking the value of x that suits it, we get an answer of 1. Another way of doing this is to go to the graph and draw a horizontal tangent at 5 and see where it cuts the red curve. So it cuts the red curve at 1. The diagram shows the graph of y equals f of x. Find f of 1. So f of 1 would simply be going to the 1 on the x-axis and seeing where the point cuts the black graph. So the black graph is already given in the problem here. So we just go to 1 and see where this cuts off. So this is negative 1.3, and this is the answer to A. For B, we are required to solve f of x equal to 3. So 3 here would be this horizontal line. And we want to see where it cuts the curve. We want the corresponding x value. So the corresponding x value here is just negative 0.5, and hence this is the answer to B. For C, we are told the equation f of x equals k has only one solution. Write down the range of values of k for which this is possible. So again, we want to draw a horizontal line that cuts the curve only once. So in order to do that, let's try a couple of different lines. This line, for example, cuts the curve only once. This line cuts the curve only once. Just focus on the black curve. This line here cuts the curve 3 times. And this purple line cuts the curve exactly twice. So this purple line itself does not work. However, any line above the purple line would work. So anything above this number here is -4. So k is greater than -4. Not greater or equal, but absolutely greater. It cannot be -4. By drawing a suitable straight line, solve the equation f of x equals x minus 5. So of course here we have to draw the line x minus 5. We can put x as 0 and 1. Y will be -5 and -4. So we draw this point, we plot this point and this point on the graph, 0 and -5 and 1 and -4. This gives us the green line. So I used these 2 points here, for example, to draw the line. And this green line, we want to know where it cuts the curve, the black curve. So the points of intersection here are this point in green again, and this point here, and this point here. What are these numbers? These are the x-axis representations of these points. So for example, if we just go up all the way up to the x-axis here, we will get -1.50. Same thing for here. This is 1.35. And finally, for the third point here, I'm doing this roughly, of course, but if you do it accurately, you will get the same number that I did, which is, for example, here, -2.2. And again, I remind you that you have to watch out for the ratio between boxes and units because it's not the same in every graph as you saw in the previous problems. So the 3 values in green were written as solutions to question D. Finally, in E, we want to draw a tangent at x equals 1. So this is the red line drawn on the graph. We've done this multiple times before. You draw the tangent, you take 2 points far away from each other, and you calculate the slope. In question 7, we are told complete the table of values for y equals 3 cosine 2x. This is our final question. I included it here because this is the first time we get a trigonometric function. You don't really need knowledge of trigonometry to solve this. However, all you have to do is follow the same protocol or procedure that we followed in the previous problems. We plug in these values here into the equation to get the y values. After we do that, we draw the graph, same as always. For C, we are told use your graph to solve the equation 3 cosine 2x equals -2. So 3 cosine 2x is the graph that we drew. So we just need to draw y equal -2. Y equal -2 is the green line that is drawn on the graph. And we see where it cuts the curve. And roughly, this is 66.5. So this is my answer to question C. Finally, in question D, this is the first time we see this type of question because the function is kind of different than what we're used to. We have 120 cosine 2x equals 80 minus x. And we can't see 120 cosine 2x anywhere in the problem. The nearest or closest function is 3 cosine 2x. So how do we solve this? First, let's isolate cosine 2x to begin with. So this is what I did here. I said, well, let me resolve it so that you are following better. So we start with this equation 120 cosine 2x equals 80 minus x. Now we want to make this turn this into something similar to 3 cosine 2x. So first thing I'm going to do is divide by 120. And then the next thing I'm going to do is I'm going to multiply by 3 on both sides. This way, on the left, we have 3 cosine 2x, which is the graph that we already drew. And on the right, we have this expression, which we can graph as well. This is not a very difficult function. It just looks kind of weird. So 3 and 120 can be simplified. So this becomes 80 minus x over 40 equals 3 cosine 2x. I can even simplify further by taking separate fractions. So 80 over 40 is 2, x 2 minus x over 40. So now we just want to graph this line here. put x as 0, and then maybe put x as 40. So if x is 0, y is 2 minus 0, which is 2. If x is 40, y is 2 minus 40 over 40, which is 2 minus 1, which is basically 1. So you have 0, 2, and 40, 1. So 0, 2 is the blue point here. This is 0, 2. And then 40, 1 is the other blue point right there. And I join them together, forming the blue line. And I see where the blue line cuts the red curve, which is at this point here. I find the x value, and the x value is 33.5. This is the simple solution to the problem. You can check the answers. So 32 to 36, and we have 33.5. This is okay. For the one above it, we have 65 to 67 in question C, and we got 66.5. So this is also within range. So it seems we did okay in terms of the numbers. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.